Hello and welcome back. So in this video, this time around, we'll be working with the general cubic equation of state here, and what we want to do with it is to write it in terms of the compressibility factor. Why would we do that? Well, if we do put it in terms of the compressibility factor, its application in a bunch of other things increases. Not only would we be able to find specific volumes, we would also be able to find specific pressures and temperatures and such just from the compressibility factor, right? So one other thing that we get from it is if you watch the video on where I plotted the SRK general SRK equation of state, you'll know, people who know their thing will notice that the plot of it with all the different isotherms is wrong. And I'll go into that later in a different video. But towards the way of fixing that plot is by first putting this in terms of the compressibility. So that's what we'll be doing here. And just as a warning, my whiteboard is definitely not big enough for all the work that goes on into this, so I will be taking breaks in between to just erase everything. So, all right, let's start. All right, so let's get started, right? So what's our first step, right? Well, we want it to be in terms of compressibility. So what is the compressibility? It is Z, that's the letter for it, and it's PV RT, pressure, volume over our temperature. And so to get it to look like that, right, we have a pressure over here, and if we multiply it by V and divide it by RT, we can get compressibility on the left-hand side. So let's do that. And remember, we have to do it to this right side as well. So we get PV, RT on the left side here. The RT's cancel, the V takes its place. I'll just be labeling it as A. And we have RT down at the bottom here with all the other stuff. Now, what is our next step here? Well, I could say this is Z, right? I will just put it over here. That's technically Z, so we can replace this later on, which is Z. And then we could try manipulating these fractions a little bit. So let's multiply it. Let's get rid of some of these V's, right? So we could multiply the top and bottom by 1 over V. So that way it stays, we don't have to do anything to the left side. So I'll write what we're doing. It'll be multiplying this entire thing here by 1 over V to the numerator and 1 over V to the denominator. So that will turn it into, put some arrows here. Z equals, well, that turns into 1, right? And well, if we run that through, we get 1 minus B over V minus A is just on the top now. We get a RT, and since we have 1 V that goes through, it'll only hit one of those quantities, so we'll get 1 plus epsilon B V and V plus sigma B. And I just noticed I tend to write downwards on a whiteboard. Well, anyway, this looks kind of weird because we have over V's for everything. So to make it sort of similar, we could take a factor out of the V. take a factor of v out, and this is what we get. And that looks slightly better, right? Sort of fits the other stuff. So what do we do from here? Right? Also, my lighting is horrid, so I probably won't try to write that much on this right side. I only have one light source in this room, so anyway. We could try decluttering this denominator next, right? So I'll write what we'll do here. So we're going to try to move this RTV up, and to do that you multiply by the reciprocal, right? So that will be multiplied with 1 over RTV. Can't be too careful, right? At least with this we'll know where we make our mistakes. So this will turn it into Z equals A over RTV over 1 plus epsilon B over V one plus sigma B over V. And that looks a little okay, right? So I'm gonna erase the board, put this up here, and I'll see you guys in a second, and we'll discuss our next steps here. All right, so now that I've cleaned the board a little, and we have our equation here, it honestly still looks like poop. So, what else can we do, right? There's still some V's and others, and T's is still in there, right? So what else can we do? Well, let's rearrange what we used to bring to transform this a little bit. All right. So if we rearrange this, we can get V. Bring the RT over. Right? So RTC divided by B. And we get V, and we can plug that in to every single V that is in our equation. Hopefully you can see that, and I will do that, and it's gonna look even messier. Which one do you think? We're going nowhere with it, but we are actually going somewhere with it. So don't worry, I will do simplifications in a bit, so just bear with the ugliness for a second. All right, so let's simplify this a little bit. And this is just basic fraction stuff, so I probably won't need to commentate that much over what we're doing. All right, and we can simplify just a little bit more. I will rewrite the entire thing. But just so you know that all the steps that I'm taking, I'll write out every individual step. Alright, so after some of that simplification, that's what we get here. This last one, which is kind of curved diagonally down, so I'm sorry for that. But this is what we get. And because it looks so ugly, some people, geniuses, were like, man, let's make a bunch of these variables equal one variable instead, so it looks a lot prettier, right? So that's what they did. That's what they actually did. And conveniently, the way that we have it set up is exactly what those other variables equal. So I'll write it over here. In this case, they introduced I'll introduce one for now, and then I'll sort of integrate the other in a different way. So they introduced beta. Hopefully my shadow isn't making it blurry. And that specifically equals BP or RT. And well, as you can see, that is literally everywhere. So that obviously simplifies a bunch. And I'm gonna erase this portion, bring this up here, and we'll do the inserts. We'll insert beta into everything here. So give me 1 second to erase everything. All right, so now that I've cleaned everything up, here we are. And we have our beta, right? So let's start replacing all our BPRTs with beta. And that we get this. Minus that shouldn't be down that low. One plus epsilon beta z 1 plus sigma beta over z. And well, what do we do with this part? It sort of looks like beta, right? Well, one part of it definitely does look like beta, but not exactly beta. What part in there looks like beta? Well, it says P over RT, right? How do we get P over RT over here? Well, that sort of looks like this, right? P over RT is beta over B. And we can substitute that in. So let's do that. Z equals 1 over C. So, all right. We will get a RT times beta B C. And the bottom stuff is the bottom stuff. All right. And, well, they're like, wow, that still looks like crap. So they were like, let's develop another variable for this part. What is that variable? Well, it's Q. Q equals A over RTB. And well, we can substitute that now. in here, and we get this. Z equals 1 over 1 minus beta Z. And there we are. And now, what is left? Well, the only thing left to do now is to turn into a polynomial so that we don't have all this fraction business. So how do we do that? Well, let me erase the board and we'll develop that next step. All right, now that I've cleaned up some of this stuff here, let's work on that polynomial. So, just so that we don't have to deal with a poop ton of fractions here, let's divide everything by z. So, divide by c, so we get 1. Oh, we get 1 equals, this is basically multiplying it by 1 over z, right? So we get z minus beta and well, now we're left with that weird thing, right? So what can we do about that? Well, we only had 1 z for this, but we can actually do a reciprocal, right? You know, this is technically supposed to be down here anyway, right? If we had to rearrange it to make it look like a fraction. So we can actually pull that into here as well and sort of make it look better, right? So I will actually erase this top part. So it's just q over beta, and we get z plus sigma beta. And here we are. And it looks so much better, right? Technically, it sort of looks like the original cubic equation state, just with a bunch of different letters. Obviously this time as in terms of compressibility. But like I said earlier, we wanted to turn this into a polynomial, right? So what do? Obviously, common denominator. So let's work all that out. I am thinking of either, I know I won't have enough space, but whatever. I will write out its general form to begin with anyway. So we will get I'll write out all my steps so that you see what I'm doing. So we won't get confused, hopefully. All right, and that's what we get when we do the CD. Didn't realize I stepped out of frame there. All right, so let's start multiplying everything out. So for now, I'm gonna erase the board and I'm gonna put this over here and this right side over here, and we'll work solely on the left side first. So let me rewrite that. All right, so here we are. So let's start multiplying everything out. Let's start, since this is over here, let's just start with this main group here. So c squared. I'll write it out first, and then I'll group them in the next step here. So we get a sigma beta z plus a epsilon beta z plus then a epsilon sigma beta squared. All right, and next, all right, and now we can start multiplying this out with that. That was probably really loud. I've been sort of whispering this entire time just because I'm using this as my mic. Sorry. Well, anyway, we have a z cubed. We then have a epsilon plus sigma beta z squared term right here. Then we have a just normal z term. And then we have a negative beta z squared. And then we have a, that shouldn't be a plus, that should be a minus. We have a minus epsilon plus sigma beta squared z term. And finally, we have a minus epsilon sigma beta cube term. All right, so that's everything on the left-hand side. I've kind of written into the right-hand side. So I'll wall this off. Well, we know that this portion is the right-hand side, right? So I will wall this off, actually. Right, so we know this is that, so we can write that, just copy it again. It's simplified version, actually. Sigma beta z plus epsilon sigma beta squared. Right, and this is a super simple multiplying out, so we get minus q z beta plus q beta squared. All right, and these are equal to each other. And we wanted to set it to 0 because we're going to be finding the roots of it later on in the next videos. So let's sort of, I guess I didn't have to put those in the parentheses. Let's sort of collect all our cubic, squared, and z and constant terms into columns. So I'm going to actually erase everything here, put this whole finished stuff up on the top. Hopefully I get it in a way that it fits, and I'll draw the columns out too. So let's do that. All right, so now I've rewritten everything, and I had to write it smaller just so that I could fit all in the top row. So hopefully you guys can still see that. And I've written here z cubed, z squared, z and constants. Those are just headers to help fill in all the separate terms, sort of like sort them out in a way. All right, so let's start with the z cubed. Well, we only have one of those. It's this one right here. So I will say 1 because 1 z cubed. no coefficient, so just 1. Z squared. Let's go left to right here. Well, we have this, we have this, we have this, and that's it. So since we're moving everything to the left side, this will be positive epsilon plus sigma z squared. We have a negative beta z squared. This is moving over, so we have a negative 1, and that's it. Now for just regular z's, I will do, what type of underline? Maybe I'll just do circles. All right, that one, that one, that one, that one. All right, so we have a epsilon sigma beta squared. We have a epsilon plus sigma minus squared, and we have a epsilon plus sigma beta, also negative, coming over, and we have a positive q z beta. And now everything that's not marked is a constant term, so I'll just do a box, maybe. And there we are. That is every term left. So we have a negative epsilon sigma beta cubed. We have a negative epsilon sigma beta squared. And we have a negative q b squared. All right, and there we have it, all the coefficients. So if you were to write it, it would be, I guess I'll just write it then. It would be z cubed plus epsilon plus sigma z squared minus beta z squared. Oh, oops. That isn't supposed to be there. Oh, I used the wrong side of the eraser. There's no supposed to be z there. It's just supposed to be beta. And minus 1 z squared plus squared minus epsilon sigma beta squared. Now there isn't going to be enough room. I wrote the z there for some reason. It's supposed to be qb, q beta, I mean. C, and plus this constant term, which won't have enough room, so I'll put it a little bit down. You guys can't see that right now, but give me 1 second. That's all equal to 0. All right, and there's our final thing, which we'll be using in our next videos. But this is how you sort of take the generic cubic equation state and do it in terms of compressibility. And this is what you get. So, thank you for coming along in this mess. And I just realized I wrote z here when there's not supposed to be a z here. And I probably wrote it here too, which I did. And that's fixed. All right. Awkward silence.